Now then, I'm Matt Chivers, and this is my 7¼ inch gauge Tinkerbell steam locomotive build. I started the project back in 2019 after many years of talking about building one and dreaming about building a steam locomotive, and then I started looking at projects that I could actually build. And after a few discussions with my friends and people that I know, I ended up settling for a Tinkerbell 7¼ inch gauge Tinkerbell locomotive. They are known as Tinkerbells after the first one that was built in, I think it was 1968 by Roger Marsh. And obviously the first one was named Tinkerbell, so it became a very popular locomotive to copy, build, and you know, as the years went on, people kind of adapted the design to something that they envisioned in their heads. Now these Tinkerbell locomotives, they're quite large locomotives, especially to run on 7¼ inch gauge track, and you know, over the years people have extended them. They've done different wheel arrangements. You'll find a lot now that have full enclosed cabs. There's many that are based on larger real prototype locomotives. The steam engine itself, most people use the valve gear that's based on a Hayward valve gear, and then there's quite a few now that they've adapted the Walschaerts valve gear onto them, which is that's actually quite pretty on a Tinkerbell, is the Walschaerts. So something maybe further down the line I may look into building another Tinkerbell with Walschaerts valve gear, but for this build we're going to use the Hayward style valve gear. Now, if you'd like to know more on Tinkerbells, Paul Ash has written a little book called The First 50 Years of the Tinkerbell, and it covers everything from the early history of the original Tinkerbell through 50 years of various designs, and there's a number of different types of Tinkerbells in the book. It's a great little book, definitely worth getting if you're interested in this type of locomotive. There's also a great Facebook group called Tinkerbells and Variants, which is full of really knowledgeable people. There's a handful of us that are slowly building a Tinkerbell steam engine. It's yeah, definitely recommend that, and definitely recommend the little book. But other than that, just, you know, go do a Google search and the images, and you should find all sorts of different types of Tinkerbell style locomotives. But yeah, so right now we're going to see where we're up to, which is really not a lot of progress in just over the 12 months that I started the project properly. But yeah, let's have a look and see what we've got up to. Right, so the laser cutter has just dropped off a bag of lots of lovely pieces for the build. We've got bits for the pony truck, we've got the cranks, we've got some the back piece for the frames, basically a frame spacer. We've got the pieces to hold the bearings in on the mainframes. We've got the tread plate for your feet, where your feet go. And we've also got an extra buffer beam. Right, so back in late 2019 I had the 2 mainframe profiles cut and the 2 buffer beams cut for the project. They didn't contain all the holes that are in them now. They were pretty much the profiles. I had these 2 holes. There was 4 holes there and a slot. I'll come back to this section in a minute, but we'll start with the buffer beams. These are just 12mm mild steel. Obviously I've drilled all the holes for the angles to bolt them to the frames. All the angles have been drilled, ready to go. But looking through the Tinkerbell Facebook group, it's quite common to have a thicker front buffer beam to allow to give a bit more weight at the front, because these locomotives are quite out of balance. So I've ordered another 12mm plate, and I'm going to match the holes to the front one and then possibly just stitch weld it just to keep them together to give a bit more weight on the front. I could have gone for a 20 or 25mm front buffer beam, but I thought, as I had one already, I didn't want to waste the material, so I just thought I'll double it up, and we should be alright once we smooth it all out. Right, so moving on to the mainframes, get these out of the way. So moving on to the mainframes, I did make a bit of a schoolboy error when I drew them. For some reason, should I say, when I did the bearings, I did them I set them for springs that were only 41mm, not 51mm. So these holes, the lower holes are for the brake gear. The top one is part of the reverser valve gear assembly section. Correct me, you'll know some terminology. So this bit is out. I don't think the slot I don't think that's going to make much difference, because I made that quite long to start with. So I've had some pieces cut that I'm going to weld in, so I can move the hole to where it should be. Now, all the holes that you do see have been drilled over the last year, as I've been slowly working out how these things go together. We've had the guides for the bearing. We've also had that one. Yeah, that's that one. That goes there to hold the bearing in. There's also a piece of angle there just to give it extra strength across the horn. Is that the horn? Is that the whole axle bearing hole? And the latest thing I've done on these is drill these top holes, which is for a strip of angle to go all the way down. So here we've got the wheel sets for the drivers. They are Ian 8.5 inch diameter on the tread. This is the rear set and this is the front set. The difference being in how the suspension is. The front just has a spring in the bearing like that, but the rear a little bit more complicated. This is the suspension for the rear. This effectively floats on top of the bearing, and the suspension is done by these spring hangers. These angles are welded to the frames, and then obviously as the wheel pushes up, this section takes is the suspension of it really. It takes the pressure. 4 springs per bearing on each side. This is because the locomotive is very much out of balance. It's got a lot of weight on the rear end, so we actually need to push effectively the rear end of the locomotive up, which is why we're doubling up with the front buffer beam. We're putting a heavier duty suspension on the back, and we can also get a bit of adjustment as well when we set this up on the locomotive. Once the boiler's on and all the cab, we can actually get a little bit of adjustment out of these springs, because they have nuts on the bottom tighten up, so we can actually push the locomotive up or sit it down if we wanted. Obviously, on the end of these axles are the cranks, which they sit. This hole needs obviously machining out to suit press fit there, and obviously the hole for the crank pin needs machining out. But these have only just arrived, so we've not done anything with them yet. Obviously these axles are, I don't know if you can see, they are keyed. I'll try and get a picture of that in the video. They are keyed on the axles, obviously 90 degrees out for quartering. So we swapped the rear driver out for the pony wheel, a very small pony wheel. This is a 6-inch diameter on the tread EN8 wheel. It might be a little bit too big for what we're doing, but if I need to buy if we need to buy another one or swap it out, we can easily do that. Obviously these have the bearings. Now, as I've read it on the Facebook group, this one takes a 32mm long spring, and then the plates obviously arrive for the rear pony. I want to get in there. They'll sit like that, and then obviously you've got the plates. Let me grab one. No, I've not got one. Plates to hold the bearing in line. Goes there. We've got a piece that goes across the top to the other side. There's a couple of pieces in the middle. I think I'll probably end up doing a video on building the rear pony. There's quite a bit of work in that yet. But yeah, there's the rear pony. Right, so we've marked up the first angle iron. As you can see, I have put some centre pops in all the way along. Just marked them with the chalk so you could see where they were. They're just over 150mm centres. I think there's 11. It should be enough to start with. Yeah, so let's get to the drill. Right, so first I'm just going to drill them all out with a smaller hole first, and then open them up to 8mm. And then I'm going to use my countersink and just take off any burrs either side. This is something that I prefer to do when drilling holes. It's always a pain if you've managed to blunt your drill and then get a burr on the back where you've drilled through and cut your fingers. Never nice. So yeah, I just use just a countersink and just take those burrs off. So let's get going. Don't forget your cutting fluid. Right, so the bearing. Literally all I do is I just use a countersink. That's it. Just let it touch, and you're done. You're sorted. Off we go. It was a little fast, really. Maybe I should turn it down a little. Right, so we got the angle iron on. I've just bolted it on just to see how it fits and see if it straightens up the frames, because obviously the frames, when they come back from the laser cutters, they do tend to have a little bowing. This one seems to have come out really straight. The other one, I might need to put the other one in a bender and just tweak it until it's straight. I've only trial fitted the angle for now. As you can see, I've notched out for the bar for the brake hangers here, where the bolt goes in. There's one at the very front as well. The other thing I've quickly made is, I'll just move it down, is these brackets here. These two brackets will be supporting the tread plate floor. Now what I've done here is I've tapped the 10mm side frames, M8, and then I'll probably end up just putting a bit of Loctite on the threads just to make sure they never undo. Right, that's it for this episode. Hopefully next time we'll be getting the welder out and welding on the brackets for the rear suspension. We'll fill in these holes for the schoolboy error that I made. We'll be getting the buffer beams together and drilled, and we'll see where we go from there. Like, subscribe, all that shenanigans, and see you next time. Laters.